Hi everyone, welcome to Math Spellbook. I'm your host Peter, and basically we're going to continue on to where we left off last time. Hopefully you guys are having a great middle of the week. You finally made it to the middle of the week, so congratulations to you all. Now the weekend is just up for it's just a couple of days away, so hopefully you guys will be able to have some awesome days ahead of you before the weekend occurs, and then you'll be able to rest if you rest on the weekend, and if you work on the weekend, hopefully it won't be too much of a hassle for you. Anyway, let us just begin. So I will disengage my model for us, and then I will do the study timer. There we go, and let us begin. Alright, okay, I just wanted to make sure my mic was on, just in case. Okay, now. So I think we were on problem number 11. No, we did 11 already. So I think we were on 12, so. I don't know how many of these problems we're gonna do, but let's just hope we can get a good handful of them. So yesterday was pretty fun. We actually learned about thanks to Sascha, we learned about the fundamental theorem of arithmetic. That was a big experience, and if you guys haven't checked out that VOD, it's on YouTube, so you can just go onto my YouTube channel and check it out if you haven't checked it out yet. I always upload my VODs on YouTube. Unless unless there was some circumstances where I couldn't record or anything. So the question we have today is, if x is an element of R and x is 0 is less than x and x is less than 4, then 4 over x times 4 minus x is less than is greater than or equal to 1. Okay, this is an interesting one. So basically we're given, okay, proof. Suppose x is a real number and x is 0 is less than x. So we're given x. So now we have to given this expression. Do this by a case-by-case basis. Because it's direct proof, so we can basically just if we did the natural numbers, basically we'll have a range. Because like if we had like a case 1 where x is equal to 1, then we would have, which would, this is like scratch work, this is not but then if we had case 2 where it's like x is equal to 2, then we would have then we would have 2 minus 2, we had 4, and that equals to 1. And then we have case 3, where if x is equal to 3, then we're left with 3. So the point is not to solve for x, it's just basically it's basically just getting this expression to actually show the result we're talking about here. But these are the natural numbers, but given the range, so if it was 1, and it can equal to 4, so we're given these 3 cases here. I'll just write scratch work, so, because I don't think this is going to be involved with the proof. is that are equal to we're kind of given a range where it's like it lies between. I have to remember my fractions so I don't like mess up. Okay, so it lies between like 1 and it's like 1. So x cannot be 0, so actually I want to see a little experiment, just calculating like how, like if it was really close to 0 then the closer it gets to 0, it basically kind of blows up. And I think with 4 it's probably going to be the same. Like if the closer it gets to 4, it will eventually like, I think it'll probably, let's see. So 4 divided by 0. Seems like it's going closer to 0. So before it gets to 0, in this case, it goes closer to positive infinity, and the more it gets closer to 4, it's getting closer to 0. I mean, it's an interesting dynamic here. Hey Sascha, how's it going? Let's see if there's something in the book that can help us here. What's the best part of your day so far, Sascha? Cases. So it does go through cases in this part. So how do we prove this? If x is an element of R and 0 is less than x, and x is less than 4, then 4 over x times 4 minus x is greater than or equal to 1. have to do it by case basis. But then again, it's the real numbers though. I'm doing the exercises for linear algebra class that I'm TAing. Ah, I see. Nice. You are a good teacher though. I will say that for sure, Sasha. Yesterday's stream was like very, very informative. I mean, I did separate it by case, but these are just natural numbers, 1, 2, and 3, but it gives us a range. I don't like the way I drew that arrow there. So this is where less than 1. Then this is, let's just erase this part. And this part is when it's doing a very painful exercise of computing normal Jordan form. Oh, for a 5x5 matrix. Ugh, that sounds, yeah, that sounds pretty ugly. No. Drag that down there. How do I prove this? Because I mean, I did prove it by case here. The thing is that I don't think this would include all the rational numbers. Unless I basically show these cases here and then basically write the ranges. We know it's not going to be 0 because it's less than 0. It's greater than 0, so we don't have to worry about this infinity here. It's just that I don't know how to clarify this, or at least write it in a way that looks mathematically elegant. For some reason I keep thinking that maybe I'm just making it too complicated. So maybe... So we'll just erase this for now. Because what we want... Okay, so 4 is on one side. And let's just say for the sake of argument that 4 is greater than or equal to x. Maybe we're supposed to use this to help us actually. Let's see if that works. So let's just minus 4 on both sides. Well, not both sides, what I mean is see how they write it down in the answers. Let's see. Direct proof number 12. Okay, so yeah, suppose. Oh, okay. So the way they wrote it. Okay, so they said, so proof. Assume. Then. Which implies. Okay. So the way they wrote it is that assume that 0 is less than x and x is. Hey, Side Buzz. What's the best part of your day so far, my friend? Then -2 is less than x minus 2. That is less than 2. So squared is greater than or equal to 0. probably try one more proof question. This one I probably have to look over because I'm like wondering how is it. So we know that this, then this minus 2. Okay. And then they basically simplified it. Actually, I feel like right now I feel like I haven't done physics in a while, so maybe I'll probably do some physics problems. So book of proof. Do the first one. Let's see, a squirrel has a y coordinates of 1 point meters at time 0, and the coordinates time 2 at 3 seconds. Time interval, find A, the component of the average velocity, and B, the magnitude and direction of the average velocity. Okay. Alright, so actually we probably should write R. Have to do it by coordinates. Here to make it more room. Then we have 5 minus we'll put a J here. And then that's also 3 seconds. point for you guys to see. I have to remember to put in the calculator that we have. There we go. Divide that by 3 seconds. Plus 3.4. That by another 3 seconds. Just want to make sure my logic is right. Hey, congratulations, Sasha. Oh, you guys can't see the calculations. My bad. I'll put it right here. Alright, so we got those. Now, the question's asking, for this time interval, find the components of the average velocity. The average velocity we have, I think we have part A. And B, the magnitude and direction of the average velocity. Okay, so magnitude should be no issue. So we have plus, negative. Then we can bring up our calculator again. Let's clear that. There it is. Square root of 1, 4, carry the plus so we have a magnitude of 4 point. And now for the direction. So now that's theta. Sine. Cosine. Or x over y. Y over x, I should say. Change this in degree mode. Mode. Yep, it's in radians. I thought so. I was like, that doesn't look right. Okay, So let's do that again. I was like, it's -1 radian. I'm like, no, that's not what I wanted. I wanted the degrees. Wait, did I change it? I probably didn't. Let me see. Mode. Oh, it's still in radians. Oh, I have to enter to save it. Okay. That explains it. Okay, -70 degrees. Let's see, when you have, yeah, so it's like we have negative y and then we have a positive x. So yeah, that makes sense. Well, -70.2 I should write, or 0.3. -70.3. And if you add 360, roughly 289, 7 degrees. So we have this, and these. I'm not sure about the paradoxical aspect of computing the Jordan form of a 5x5 matrix. I spend most of my factoring in characteristic polynomials. Well, that's how it be sometimes. Hey, Penn Center. Lurking today, but I hope you're having a magical day. Thanks, Penn Center. And if you guys are not familiar with Penn Center's work, he is also a math streamer. Basically doing streaming maths from real analysis to linear algebra. So if you want to check out his content, please check out his content. Very informative, as well as feels like you're in for it feels like you're in a math lecture without the student debt involved with it. So I think that's a plus. So be sure to check out Penn Center whenever you guys get the chance, because I'm pretty sure you'll learn a lot more stuff from him and his awesome community as well. Oh, I did not know he had a cute dog. Okay, University Solutions. We're on chapter 3. So, oh, they actually have it here. Okay, so let's see if we... Thank you for the follow, Penn Center 1. I didn't even know there was like a 1 and 2, like a Penn Center and a Penn Center 1. This is my monitoring account, so I know who is online when I'm streaming. Oh, okay. I see. I was like, There's two pen centers? What? I was like, wait, what? That's bizarre. What did I do wrong here? Yeah, that's the first one. We got that one right. Did I put the wrong number in? Let me see. Maybe I did the calculation wrong. I usually screw up when it comes to the arithmetic. No, that's what I have. I mean, I did the techniques right. It's just that the numbers they put in are... like, the number for the x coordinate seems off. I mean, the y coordinate is off. Yeah, because I did the same exact thing that they did. Huh. My evil twin. Well, hopefully your evil twin doesn't try to compel me to help them take over the world, because I would be terrible at formulating a good plan for that. Yeah, that is bizarre. Unless this is from an older edition. Well, no. No, I think they just have the numbers wrong. That is really, really peculiar. I guess, like, sometimes they do that. Like, sometimes, like, textbooks, like, screw up there. But at least we did the techniques right. Let me just make sure, because I have my other like, out of habit, I know I should, like, do the calculations in front of you guys on the calculator that's on my tablet. But I'm so used to, like, grabbing my calculator, like, because it's next to me all the time. Plus, unless I think I entered probably the numbers wrong here, so let me check. Nope, that's correct. Okay, never mind. Okay. I think let's go into the next problem then, because I think we did that problem right. It's just that they did something weird with the numbers. I don't understand why that is. Let's see, a rhino is at the origin at time t, so it's at, so we can just put it as 0, 0. Because I'm thinking it's going to be like y and x. Yeah, because we have like I, yeah, so. Okay. At time 0, and the second time is 12 seconds. The rhino's average velocity at the x component and the y. Okay, so the velocity vector at time. Okay, so we have the velocity vector here. So that is negative. No, actually, I should write it somewhere else. Make it easier to see, because that doesn't look nice. Alright, so the velocity vector, I think that's the final velocity, is time 12 seconds. Okay, so the question is, what are the x and y components? Oh, I should say, it says coordinates. Coordinates rhino and B, how far is the rhino from the origin? Okay, so we have the velocity, so which means we're going to have to integrate. And the initial velocity, I'm guessing, is 0. So I'll just write that there. Initial velocity is 0, 0. Okay. So I'm like, so right now I'm just thinking like how I should best approach this. Oh, break time. At least like breaks started like before I started another problem, but at least like I can do the simplest of physics problems. Simplest. It's hand wavy because for me I've kind of exposed myself to like, you know, like kinematics for like a lot, but I have to reintroduce myself to things like, you know, the springs, the angular momentum, obviously problems involving work, like work between the work, what is it called? The work energy theorem, like with both potential energy and kinetic energy. Those I have to actually like get back into, and I don't even remember anything about electricity, like anything with electrical circuits and stuff. I have to actually reintroduce myself to that too. I think with physics I have to actually like try to do more with physics because I want to be able to like do these problems as if I'm remembering the quadratic formula like I did with math, because I think with math, like obviously, like, you know, the easiest algebra problems I can probably like see and do, but when it comes to like recalling, like, you know, the basic physics problems, I kind of like only remember a certain portion, and a majority of it is kinematics. Let me see here. And if you guys are tuning into the stream for the first time, welcome, welcome, welcome. If you're lurking, it's okay, you can lurk. And, you know, hopefully, like, our stream is, like, giving you the mood to be productive in whatever things you're doing. It doesn't have to be math or physics. It could be just, like, studying as well. You know, like, you can just be also sketching if you want. And hello, Zach. I'll actually give you a shout out too, Zach. So if you guys are not familiar with Zach, aka E to the 2 I pi, he also is a math streamer, very, very knowledgeable. I believe Zach is also a professional mathematician, so he basically teaches a lot on series. So and I believe he also teaches linear algebra as well. So check out his content as well. He also vibes and he does a good job of answering people's questions. So very, very knowledgeable people in the chat so far. And also, yeah, like if it's your first time on the channel, drop me a follow if you would like to have a productive study stream in the background for you to be productive. And also, you can follow my YouTube channel as well. Under some definition of professional. Pi, we don't talk about the we don't talk about these strange twins. Very funny, very funny, very funny. You guys are hilarious. You guys are hilarious. Yeah, like even like I like getting back to what Sasha me were talking about yesterday. When we were talking about the fundamental theorem of arithmetic, that was a lot of fun yesterday. I felt like even though like I was answering some of Sasha's questions that he kind of posed to me, it's like, oh, what idea can you get from this lemma, or like what is it in the proof that we have to do in order to like show this contradicts or something like that. I felt like I wasn't doing as much work as like he said. I felt as if I was just like trying to connect the dots, and I was just like doing it mentally in my head. So like it was but he was a really awesome guy to actually show me like what is it that I need to think about for the proof, and I think that was really, really informative. I felt like I did gain a lot from that experience. Like I still remember like when he was discussing with me, it's like why is it that like if you have like a number that is a divisor to another number, why is it that the obvious one is basically the divisor equaling the multiple? And I thought that was a really interesting perspective, because then I was thinking, then I came up with the conclusion that the multiple can't be higher than the divisor in that way. So like if you guys haven't seen it, you can check it out on my YouTube channel. We discuss like the fundamental theorem of arithmetic there. Like I don't know if we go into too much detail, because we did not talk about uniqueness in that VOD, but it was pretty informative. I quite enjoyed it. Trying to keep it real. Why you have to go and make things so complicated? We have a very complex sense of humor. Actually, speaking of complex, like I remember like watching videos from like people that are doing theoretical physics plus along with mathematics, and I noticed that they bring up complex analysis a lot when it comes to like quantum mechanics, but I always thought you had to learn real analysis before you went into complex analysis. Or am I thinking of a different course, like involving complex numbers after real analysis? Because I always thought complex analysis was like after real analysis. Or it can be. I don't know. Because like the reason why I switch from math and physics a lot is because, one, I feel as if I don't know physics problems as well as I know like basic algebra problems. Like when I say basic algebra problems, I mean like things like factoring and like basically solving for x and all that stuff. Yeah, I feel like I don't know like the basic physics problems from the back of my hand. I remember the equations such as like momentum is like mass times velocity, like the basic stuff, and kinetic energy is like half times the of the mass times the velocity squared. I would remember stuff like that, but when it comes to actually solving problems, like some problems like occur to me here and there, but at the same time I kind of like feel like I don't fully remember like how to do the techniques unless I see the problem like firsthand, and my mind is like, blah, 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 you've done this before, go back into the memory banks. Complex analysis is a different beast, but you usually learn real analysis before complex analysis. Yeah, that's what I thought. I would say complex analysis is by far one of the coolest subjects in undergrad math. Yeah, that's why I want to like learn real analysis so I can get up to that point. But then again, I haven't taken multivariable calculus, or at least like do the techniques to perfect like multivariable calculus, because I have taken Calc 1. Calc 1 stuff, like, I feel like I'm decent at, because I remember, like, the derivative rules. For Calc 2, I feel like I barely remember, I barely remember, the, the series. I forget series a lot. Like, I know the test, I just don't remember, like, doing problems involving the test. And I think that's the thing that I'm lacking when it comes to Calc 2. And I know I need series if I need to, because when I took Calc 2, I took it in the summer, and we didn't even do Taylor series because we were just so short on time. I think the last thing we covered was, I don't even think we did power series then. Yeah, and like my teacher was a pretty good teacher actually. So, like she knew her stuff, and she made it kind of challenging for us. But yeah, we never covered power series, I think. And I was kind of looking forward to actually doing Taylor series. But then again, when I was in that class, since it was a summer course, I didn't have time to actually like come up with techniques to actually better not memorize, but remember the infinite series. So yeah, or at least the infinite series tests, and put them into practice. So I feel like I don't have much when it comes to that. I know when you do differential equations, you begin to remember stuff from Calc 2 much better, which I think is much better for me to reboot the knowledge I have of Calc 2 than just doing Calc 2 all over again. But for Calc 3, I don't know. I know things like gradient and divergence and curl, but I don't know what else do you need to know from there, because I don't know anything about Stokes' theorem. I don't know anything about Green's theorem. I don't know any of those. Like, I know how to do partial derivatives, and I think I can do some triple and double integrals. Some, the basic ones, not like the more complicated ones. I agree though. I do like I want to get to the level where I can do PDEs, but I feel like I'm not at that level yet. I do like to read about it a bit, but then when I get into PDEs, they just talk more about one equation, and they talk about all the parameters involving that equation, and I realize that I feel like I have to know like everything patterned down with differential equations before I can jump into PDEs. I love reading them about them, but it's like when I read the first part of PDEs, it's like, oh, here's the heat equation. Let's talk about all the parameters involving the heat equation. And I realized that, oh, yeah, we're going to go into much depth with this. So it's going to be a lot of reading and a lot of like breaking everything down to the T. And I realized that I was like, I probably should do much more math before I get into this subject. I don't know, like if you guys think I'm making a big deal out of just like intimidation, like just let me know. I sort of have a hate-love relationship with PDEs. Yeah, like, you know, like especially non-linear PDEs, I'm pretty sure those are like things that scare mathematicians a lot, especially if they're not used to them. Because I think like all the stuff, because I think you guys told me in chat, like all the stuff you learn in the classes, whether it be ODEs or PDEs, it's all about the linear versions of those. But then like in class they don't teach you the non-linear stuff, like the non-linear differential equations or the non-linear partial differential equations. I think like one of you guys mentioned that. Looks like you mistyped it. Love relationship with PDEs. I mean, Fizzbuzz, do you love PDEs? It sounds like you really like PDEs. if you're correcting Sasha about that. Like, yeah, I mean, like, the thing of it is that, like, I'm, like, divided between, like, two ways. Because, like, a part of me wants to learn mathematical proofwriting. Yeah, like, a part of me wants to learn, like, proofwriting so that I can, like, see the beauty that mathematicians experience. But at the same time, like, I want to know proof methods so that I can apply them to, like, things like theoretical physics and stuff. Now, of course, this is a hard journey for me, but it's sort of like, but it's mainly for fun. Like, for me, it's like for fun. Like, because I don't see myself doing a PhD or do anything epic like that. Like, I think it's really fun just to, like, engage with the material and basically, like, see what contributions you can do. Like, even as someone who's, like, outside of the field, like, outside of academia. But, like, how many people in chat love PDEs? Just out of curiosity. Because I think PDEs are fascinating, but I'm pretty sure they're pretty complicated. PDEs, boo. The only reason why I like PD, like, I like them, but I'm pretty sure that if I were learning the strategies of actually, like, trying to solve them, I would probably get a headache. The reason why I want to learn PDEs is because they're in Einstein's field equations. But of course they're non-linear, so they're going to be much more of a headache. PDEs don't have enough linear algebra. Oh, I see. I've done nonlinear PDEs in a semester class, seminar class, even at the research level. The method feel a bit, and it doesn't really have geometric intuition. Oh, I see. Yeah, I don't know what type of, like, the way, like, because I think, like, mathematicians have different ways of interpreting, like, math in general, because, like, or, like, people that love math have a different, like, I guess, mathematical mind construction. So it's like some people that love math, like, they either love dealing with the geometry of things, or they love to deal with, I guess, like, the moving things or moving variables around. So, like, I guess, like, my question is to you guys is that what type of like, I guess, mathematical mindset do you guys have? Do you guys like mostly like geometric visuals, or do you guys like mostly like messing around with like variables and moving them around to see if it basically creates a proof that looks beautiful, even though people can't visualize it? Because I've been like thinking about that for a while when it came to me in math, actually. Because, like, even though I love math, like, if it's more abstract and it's not like tied to something that I can visualize physically, I feel as if it's like cool, but at the same time I ask myself, it's like, where can I visualize this so I can actually see what system this applies to, or what pattern it applies to, if that makes any sense. Because I know the higher you go into physics, the higher math it has to be, and then it becomes so I don't want to say convoluted, but it becomes very absorbent in math that it feels as if it's like becoming math in some way, but it's revolving around the field of physics. So it sort of like has like sort of like a weird relationship, I guess. Definitely more geometric, but I prefer the algebraic method. So what's the difference between the geometric method and the algebraic method? Is it like when you do the geometric method, you have to present more graphs or more visuals on what the math illustrates? Whilst in the algebraic, do you have to like show it more like in a, I guess, an axiom type of approach? Or axiom slash like equation type of approach? Or formulation, I should say, not equations. Because I mean, you guys that are basically writing mathematical papers, I'm like, dang, like, you know, like writing like a whole research paper on like one specific topic, I'm like, that's like real commitment. For me, I'm very scatterbrained when it comes to it. It's like, I want to know more about quantum gravity, but at the same time, I want to know more about cosmology. I want to know more about what made the universe and all that stuff. For me, I find, like, you know, like, obviously there's so many different theories out there, like, you know, for quantum gravity, but I would have to say I really am interested in the subjects that are like possibly out there, like when it comes to those topics. Because I'm like basically every time, like when I think about a study method I should employ when it comes to like math and physics, I try to make sure that I learn math and physics conjointly. So it's like, okay, I'm learning this math because it involves this physics. I'm learning this math because it involves this physics and all that stuff. But of course I'm not doing a very good job of that. Because sometimes I end up doing something else. As the famous Japanese mathematician Hironaka once said, with algebra, do really cool stuff without knowing what you're doing. Oh, okay. Yeah, I agree. Because, like, I think, like, for me, I would like to mess with equations and formulations on a board and just basically move stuff around. I think that's really, really, like, people might find that very intimidating. I just find it very funny. Like, very, very fun sometimes, and funny. Like, I don't know if you guys are familiar with the clip from Serious Man. Like, basically, he's Serious Man is just basically a movie about a quantum physics professor, and he's dealing with a lot of, like, issues, like, in his home life. And, like, I would always remember the scene where he's, like, writing on the chalkboard, talking about, the uncertainty principle. And I just love, like, the idea of just writing, like, stuff on the board and just explaining it. Which is probably why I do my streams, because, like, I'm able to, like, do, you know, problems, and I just say my thoughts out loud, acting as if I am, like, being a professor, like, just writing stuff on the board, even though I will never get to that level. But usually algebraic method are very formal. Oh, okay. Okay, so before we get into our next study session, I will be right back, guys. Just give me 1 second. Okay, guys, time to get the study timer out, and time to get back to doing some problems. Okay, so we are doing this problem, and I think with this one we'll probably skip and we'll probably do another problem on a different topic in this chapter. Okay, so what are the x and y coordinates of the rhino? Okay, so we have the final velocity and so what we have to do is, we know that this is the integral of the velocity, but I think we can make it simpler. Because if we do the difference between the velocities, that will give us the acceleration, and we kind of don't need that. I mean, this one is basically position and velocity vector, so I don't think we need the acceleration in this case. So at times, well, so in this case, actually probably we should put R instead, because sometimes they put R as the vector of position. And then we'll put 12 seconds here. Then I think we'll just do our calculations. Okay, so we have negative, oops, forgot the decimal point there, times 12 seconds. So then we have the vector, the x coordinate of 45, negative 45. And I think we can put the units. Yeah, because then that crosses out. And then we have to do 4.9 times 12 seconds. So that leaves us with 58.8 meters. Okay, and what else is it asking? So the x and y coordinates, I think that's it. And then how far is the rhino from the origin? So I think we can do the magnitude. At the end of the day, I'm pretty much everything geometric and algebraic. If math problem is not related to some sort of geometric picture, I really don't care about it. Oh, okay. I mean, at least you're more disciplined than me when it comes to that. For me, it's like whenever I hear a new math topic, I think about like how can we use it to revolutionize physics, even though it's not meant for that. Like when I was listening, when I was watching a Veritasium video about the axiom of choice, I was like, interesting. How can we implement that with like quantum mechanics or something like that? Even though it may not be able, you're not able to do that. I think, which is which shows how silly I am in my brain. Like every time when I hear a new math topic, I think about like how can we implement it with physics. I don't know, like based on like how long you guys have been like watching my streams, if like I guess like my question is that like what type of like mathematical mind do you guys think I have based on like the problems I've solved or how I've solved them in some cases, and what I've talked about over like the course of like my streams. I know my question doesn't sound very coherent. I'm just like, I don't even know how to phrase it, to be honest. I think for the angle, so this is oh, it's at the bottom. I think we're gonna run into some technicals we're gonna have to deal with. So in this case, I think we're gonna have to add 180 degrees because so this should be in the third coordinate. Yeah, because like No, no, not in the third coordinate. What am I talking about? No, actually, this would be in the coordinate 4. In this case. No, not coordinate 4. Because I'm mixing up like X and Y. This will be in the, yeah, this would be in the second coordinate. The second coordinate. Dang, my brain is like going off kilter today. So negative 45.6, negative 52. But I think we're gonna have to add 180 degrees. So 0.8. So we got this, and we got these. Okay. Do we still have this? No, we don't. Okay, so. Okay, so let's see what we got. Okay, yeah, we were correct there. Cool. Yeah, we got that number right. Oh, they didn't ask you to do the angle. Okay, they just wanted to know the distance. Okay. That is fine. That's fine. I'm pretty sure we would have gotten the angle right too if they asked that. Oh wait, evaluate the direction, therefore is negative, and so it's positive, so yeah, it would be in the other. Yeah, it would be in the sun. Okay, so yeah, that is, I think we got that one down. Cool. At least that answer wasn't wrong. I think, yeah, they just put the wrong numbers for like the first one. That's why it was so weird. Acceleration vector, projectile motion. Okay, let's get into this one. I've done this one already. Like, I think I've done this more than a couple times, so I don't want to do the same problem over. I want to like actually do something different. Yeah, there are a lot of people who think like that. It's a fair motivation, but I personally don't like, I don't really care that much about physics. That's fair. That's fair, Sasha. I don't, like, I don't think that's nothing. I don't think that's a totally big deal. I think it's because, like, I just feel like math is illustrating the physical universe. I mean, I like the way how it's like kind of like mathematically coherent in some ways. Let's see, what problems do we have here? Because, yeah, we're doing projectile motion. Yeah, hopefully you guys don't mind the ads, because like we finally made affiliate on the channel. Well, we've been on affiliate for a while. It's just that I know it's kind of weird to get ads when you're doing a study stream. But hey, if you guys don't want to see the ads, you know, if you can, and if you want to, you can give a sub if you like. And it doesn't have to be like directly from like your wallet. If you have Amazon Prime, you can do you have a free Prime sub. You can do that every month to any streamer you like. Probably do a 2-1. Okay, let's do the one about the spaceship here. Let's see, inside this, so let's write down the number we're working on. So inside a starship at rest on Earth, a ball rolls off top the horizontal table and lands a distance d from a foot of the table. This starship now lands on the unexplored planet X. Commander Captain Curious rolls the same ball off the same table with the same initial speed as on Earth, and finds that it lands a distance 2.76 d from the foot of the table. What is the acceleration due to gravity on planet X? Okay. So let's just draw the picture. So we have a table, and then we have a ball, and it goes off the table. So let's see, the ball rolls off the table and lands a distance. So this is d from the foot of the table. So this is on Earth, and then planet X, we have the same ball, so this velocity on Earth, and velocity on X. So this one lands. So this one lands 2.76 distance. Okay. So these two are just the positions. So we'll just label this R for the magnitudes. So Rx and RE for Earth. Okay. Now, so let's just write down the question. So that we don't lose track of what we're supposed to be solving here. So what is the acceleration due to gravity on planet X? Okay. Well, at least it's one question, because like like those like typical physics questions I see are like the next one, which is like part A, part B, and part C, and then you have to calculate a lot of stuff. Of course, science, and there's even a part E. Like when you're given say you get 10 questions for homework. It's like, oh cool, they're all in 10 parts. Okay. So now I think what we have to do is figure out, because the position is typically times time, but also we have to remember that it's minus half gravity. I'll just put a vector there to show that it's acceleration. Yeah, actually, funny thing is that it's funny that when it comes to kinematics, gravity is always negative, but when you do it in other physical, when you do it for other physics questions after kinematics, you don't have to do that anymore, which I find very, very funny, because that confused me a lot when I was trying to do other stuff like forces and all that stuff. And doing someone's weight, I think weight was also confusing, because I would always put a negative sign in front of the G. Okay, so the velocity of E and planet of Earth and planet X are the same, so probably should write that. So, or at least there's the magnitude of their speed is the same. Now So the real thing is that we have to figure out what gravity is. So we already know what Earth's gravity is. So G on planet Earth is 9 meters per second squared. And we know that our E is D. And our X is 2.6D. So we're not given the velocity or the speed. We're not given the velocity of the ball. And we're not given the time either. So let's see what I don't want to miss anything in this problem. So rolls off the same table with the same initial speed as on Earth. Find that it lands a distance. Okay. So are we gonna actually have legit numbers to work with or no? Maybe we have to use the other kinematics equation where it's like final velocity. So actually, so we know the final Can we assume that the initial velocity is 0? No. The initial velocity, so the final velocity would have to be 0, I think, because the ball rolls off the table. And then the initial velocity would have to be equal to the speed. So let's just do it for Earth first, because we already know what Earth is. Or at least like acceleration due to gravity. So we have the equation final velocity squared times initial velocity squared plus 2g times the difference in position. Technically, there should be a negative. So we can minus actually, since the final velocity is 0, we can do this. So plus, then actually let me erase that. It's too close to the other one I was writing. So we can write it like this. And the initial velocity on Earth, so 2 times, and the distance is just basically d in this case. So we're left with initial velocity, and I'll bring up the calculator to calculate the I forgot to put the square root. Square root of 2 times 9.8. So we have 4 3 the square root of d. So this speed is the same as the speed on planet X. Alright, so now we have to figure out what the gravity is for planet X. So in this case, wait. I mean, this would be the y coordinate. No, I mean, yeah, because then we don't know what d is, so we don't know what d's y component is. And then for the x component, basically if it's projectile motion, it's not going to have an acceleration. So it's just going to remain at an initial speed. So basically both, like when it comes to the final velocity and the initial velocity, so technically we know what the initial velocity is, we just don't know what g is. So in this case, we can do we can subtract and then 2g x, then divide. So g would be equal to squared. Well, actually, we can get rid of the negative sign because it's going to get rid of it. 2 so we'll be left with 3d and then 2 so then g, I think we can just like calculate the numbers and just divide those, and then we'll be left with so 2 times 2.7, and then 4.43 over 5.52. So that's left with 80, and then that is over square root of d. I mean, if we want to make it more elegant, we can just do this. I mean, that's how I would logically break down the problem. I don't know if it's right though. The thing is that it's on the x-axis. And I probably didn't do this right, I think. Because this is the x-axis. And when gravity's involved, it usually involves the y-axis. Because I don't know if the problem states how high the table is. Rolls off and lands a... Yeah, and the ship now lands on an export. So yeah, they don't tell you the table's like height. Unless you're supposed to figure that out. Yeah, I don't think I did this right. I mean, it feels like I'm doing a procedure that seems correct, but I feel like I'm doing it in the wrong coordinates. Let's see how they did it in here. I probably got it wrong, so let's see. Let's see what I missed. I probably did miss what I thought I did. This is number 3.15. So let's see. Let's see, here we go. The ball moves, projectile motions. Yeah, we know that. So, Planet X. Yeah, we didn't get that right. Let's see. What did I miss? Using the horizontal motion to find the time in the air minus G. On Earth is a... So, which is the constant... Just want to make sure you guys see what I'm seeing. I'm looking at this part right here. Okay. Let's see. They had the distance G. So I think they used the same formula, I think. Just constant. Oh, okay. Yeah, I totally got that wrong. Okay, so what did I screw up on? So the setup, what did, I see using the vertical motion find in the air, minus H, gives, yeah, time for the height. Yeah, I think I mixed it up because basically I used the X coordinates, which I shouldn't have done. Yeah, that equals D on Earth and Planet X. So the difference between the okay, so that's D. So if you multiply this with which is constant, so that d. I wonder where they got this from. Is this from like the actual? Well, let's see. Because I think they got it from this equation, because it's just that now I gotta figure out. Oh, let's see here. Which is constant. Because let's see this. So that's the velocity times the distance it went. So if you do the velocity times the distance. This is a really good question. Because they actually got like an actual number, which I was, I kind of expected it, but at the same time I'm like, what is it that I missed in that question? Because I don't want to be like, oh, I look at the answer as like, oh, I understand it. It's like, no, there was something in my brain that was like, I mixed up something. Let X be horizontal in the direction. The velocity of Y, initial Y is 0. Oh no, that's X naught. And then the acceleration is G. Gives the... Oh, okay. So they got it from this part. So basically the difference is time, height. So X is equal to D on Earth is which is equal to the velocity times time, which is this. Oh, okay. I never thought of a relationship like that. That is very interesting. Okay, well that's something that's pretty good. Yeah, because like I forget, like, you know, because we have the initial velocity times time, and that would be equal to the difference between the two distances. But then I didn't think about, you know, the time parameter here. I mean, that's a pretty unique relationship, actually. Because then the velocity is... interesting. Okay. Well, at least we learned from that. I mean, yeah, we can't get every... like... If you guys are watching this on YouTube, I don't get every answer right. And probably the more answers I get wrong, the more I learn from them. So, you know. And hopefully you guys learn from that too, actually. Learn from my experience and my mistakes. What do we got here? Is this still projectile motion? Yes, it is. Okay. Let's do number... Actually, I should probably drag it... Probably should bring it down here so you guys can see it. So let's do 21. I feel like we can try to do 21. I don't know if we're gonna have time to finish it, but we'll see. A man stands on a roof of a 15 tall building. 15 meter tall building. So 15 meters. We'll just say that's H, the height. Throws a rock with the velocity magnitude. So the initial velocity is 30 meters per second. At an angle, so theta is 33 0 degrees above the horizontal. Okay, so let's just draw a little man here, and then he throws a ball here, and then theta is right here. Okay. You can ignore air resistance like typical. The maximum height above the roof reached by the rock. B, the magnitude of the velocity of the rock just before it strikes the ground, and the horizontal range from the base of the building to the point where the rock strikes the ground. Okay. So what we need to know is, or what we have to answer is, maximum height of above the roof reached by the rock, and then B, the magnitude of the velocity of the rock just before it strikes the ground. Actually, I probably should write down that relationship so I remember the next time. So x of x equals the initial times 2hn, and then, because I can probably use this equation for determining gravity on other things. I can probably remember that equation much easier. The horizontal range from the base of the building to the point where the rock strikes the ground. Okay. Just write all the facts that we know. And the height is 15 meters. Okay. So what is the maximum height above the roof? So we know that G on Earth is negative gy, because we're dealing with 2 dimensions. Okay, so that means, so x is not accelerating, so we have the x component and the y component, which is cosine, which is 30 times cosine of 33 plus t. And it's not accelerating, so we don't have to worry about that. Like when you do like a quadratic, there's like a trick to know like the maximum. Because I think like to get the maximum height you have to do 2 times velocity over half G or G in this case. It's like a typical like math trick, because I know it's like basically you have to do like I feel like it might be just G, because the half is just basically meant for like, I think like differentiation. Let's see, where is it? There it is. Well, I'll just do this final calculation and then we'll probably end it here. So we have 30.2, then cosine of 33 degrees, and then divide that by that doesn't sound right. I think it might be like a half, because it says it takes 5 seconds to get up there, and I'm like, that doesn't seem right. So if you did this, then multiply that right here. Let's see what the answer comes to with this result. Oh no, I did the wrong thing. Let me see here. So it's supposed to be, I did cosine instead of sine. So let's just see. And then divide that by 9.8. It's a little bit less, but 3 seconds? Is it really 3 seconds though? Doesn't seem right. Let's see what happens if I do this instead. So we're left with 30, and then sine of 33 degrees, and then, oh, did we put too many parentheses? No, I don't think so. Okay, so divide that by 2. Oops. I didn't mean to clear the whole thing. Done. Second. Type this in. Divide that by 2. No, that's not right. Alright, so I think I'll probably continue this on my own. But we'll probably conclude stream here. But that was pretty productive actually. We got some stuff done. I learned some things and I realized I basically got at least one problem right. But sometimes I had to look at the answers to get a better idea of what the problem was asking. Okay guys, thanks for joining me today. It was an awesome stream being able to study with you guys. In addition, talk about some complex stuff involving I guess the field of mathematics and physics in general. So thank you guys for joining me today. And if you're lurking in the chat, if you like the math and physics streams, be sure to drop me a follow if you like on Twitch. And if you're watching this on YouTube, leave a like, comment, and subscribe if you would like to basically just have me in the background while you're doing either drawing or whatever projects you're doing, or you're just studying. I will always be available on both platforms. Anyway, let me just in the chat on Twitch, if you guys are lurking and you would like to give the channel a follow, please do so. And if you would like to join our Discord server, you're more than happy to join our Discord server. And also sub to my YouTube channel. And also, if you're watching this on YouTube, all the links will be in the description down below. And also, if you would like to check out my video game channel, my Uncle Talks channel, you're more than happy to do so. And again, if you're watching this on YouTube, the link is in the description down below. Okay, guys, thank you very much for today. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys next week. So take care, guys. Bye-bye.